Welcome to Math Blossoms, where growing in mathematics is natural. I am the teacher, Miss G, and for today's lesson, we're going to practice writing linear equations in slope-intercept form. Let's get started. Why don't we? Okay, the question is, how do we write the linear equation in slope-intercept form from a graph? We're going to show you the different representations of what you may be given on an assessment. Sometimes they show the line and you have to pull the equation from a graph. Sometimes it's a table, sometimes it's ordered pairs. So I'm going to show you like different examples of however representation it appears. You can pull that equation out in slope-intercept form. And remember, slope-intercept form is y equals mx plus b, as you can see from the image there. And the m is a slope, is our rate of change or slope. And then the b is called a y-intercept point. It is the point where the line crosses the y-axis on the coordinate plane. There's an example here of the equation y equals 3x plus 2. As you can see, the 2 is the y-intercept point. It is the point on the y-axis where this line crosses. And the point on the y-axis, all of the points on that axis start with 0. So that point is actually 0, 2, or 0b, you could say. And then the slope is positive and it's going up, so it's a rise of 3 and it's a run of 1. So that's 3 over 1, which is just 3. So we place that in place of the m. And as you can see, the y and the x are still in the equation, and that's how it is supposed to look. The x and y in a linear equation represents every xy point on that line. And since lines go for infinity in both directions, that's an unlimited number of points that x and that y can represent. So the only numbers you should have in that linear equation is the m for the slope and the b for the y-intercept point. All right, so the slope-intercept form of a linear equation is y equals mx plus b. First, find the slope of the line m by counting the rise over the run between the two exact points on the line. An exact point will fall on a corner of one of the squares and will also fall on the line. So, you can't just use any point. Like, for instance, like if you can see my cursor here, if I picked a point there, that's hard to determine what that point would be because you're between 3 and 4 somewhere on the rise, and you're also between 0 and 1 somewhere. So we're talking about fractional points there. So exact points fall on the corner of one of the boxes or squares on the grid and also falls on the line. So that's why they chose these two points, because those 2 points are exact points. Next, locate the y-intercept point, which is the point 0, b, and then write the equation y equals mx plus b form by replacing the m with the slope ratio and replacing the b with the y-intercept number. Remember, if the y-intercept is 0 or 0, then the equation will be y equals mx. So in other words, instead of writing y equals 3x plus 0, like let's say your y-intercept point was 0, we don't write the plus 0. We just know that if there's not a b on that equation, the b is 0. The y-intercept point is 0, which makes that line proportional when it is a straight line going through the origin or the 0, 0 point. So here are some examples of some some graphs that we are going to find the y equals mx plus b equation for. So of course, the first thing we want to find is where is the y-intercept point? Well, as you can see, it's crossing the y-axis right here. So my b for this one is 0. And I'm just going to go ahead and find all of the b's, if there is one. On this one, the b would be 2. On this one here, the b is -3. So we're going to put that here. B is -3. All right, so we've got our y-intercept points. And then this one here does not have a y-intercept point. So we'll just put that it's none. Because again, it's where the line crosses the y-axis. That's why it's called the y-intercept point. So if it doesn't cross this y-axis anywhere, then there is no b. Okay, so now we need to find the slope or the rate of change. So I'll change colors. We'll do, let's do green for the rate of change. Okay, I'm going to pick two exact points. It doesn't matter which points you pick. I'm just going to pick these two, and I'm going to follow the lines of the graph from each of these points until they meet. So as you can see, they meet right here at a right angle. And I'm going to count my rise squares. And since each of these squares are worth 1 going up, I'm going to count 1, 2, 3, 4. There's 4 squares here on the rise. And then the run is 1, 2, 3, 4. Also 4 squares on the run. So my slope is the change in y, which is my rise, over my run. And if I'm looking at that line, because it's going up from left to right, we always read our lines left to right. That is a positive slope. So when I simplify, 4 divided by 4 is 1. My slope is 1. So if I'm writing this equation, well, we'll write the equations last. Let's just do the slopes first. Okay, so this one is, this one is 1 for the slope and 0 for the b. Now this one here, as you can see, it's a horizontal line. So anytime you don't have a slanted line and it's just straight across like this, our slope is 0. So if you ever see a horizontal line, you can think of HOI. HOI stands for horizontal line, 0 slope. And the equation starts with y, which means every point on this line here has an has a y value that is the same, and that would be a 2. This is the point 0, 2. This is the point 1, 2. This is the point 2, 2. This is the point 3, 2. This is the point 4, 2, and so forth. Like this is negative 1, 2. Like as you can see, every point on this line has a 2 in the y position. And because of that, the equation is just y equals 2. There is no mx plus b on this one. Okay, because if you think about it, if my slope is 0 and I put 0 times x and then add my b, which is my 2 here, 0 times x is 0. And 0 plus 2 is just 2. So that's kind of how, this equation breaks down. And you just have to remember that, horizontal and vertical lines are missing one of the variables. All of the equations that are linear will have an x and a y. But if it's missing either the x or the y, then it's either a HOI or a VUX. And because we're talking about VUX, I'm going to skip down here to this one because this one is a VUX line. This one's a vertical line, which means my slope is undefined. My slope is undefined. And that's what the U means in the VUX. The V stands for vertical line. Ooh, hang on. My pen's not wanting to write. Okay, so the V stands for vertical line, the U stands for undefined, and the X stands for what the equation should look like because all of the X values, and it cuts through the X axis here, all of the X values have a negative 2 in that position. This is negative 2, 0, negative 2, 1, negative 2, 2, negative 2, 3. Down below, it's negative 2, negative 1, negative 2, negative 2, negative 2, negative 3. So as you can see, all of these points have a negative 2 in the X position. So that means the equation for this vertical line is just X equals negative 2. Okay, so HOI and VUX are strange because they don't have both variables. So your slope and your B, most of the time vertical lines don't have a B. And your B value is actually your equation value on the HOI lines. Okay, so now we've got to do the slope over here for this one. And so again, I'm picking these 2 points. I'm just going to draw some lines to connect them following the lines of the graph here from those 2 exact points. And if I count my rise is 1, 2, 3, 4 going up. And then the run is 1, 2. So if I've got the rise over the run, that would be 4 over 2. And that's going to be a slope of 2. So remember, it's rise over run, not run over rise. And the rise is the distance in y. And if you forget that, just look at your slope formula. Usually they'll give you the slope formula. And in the slope formula, it's the y values that are on the top and the x values that are on the bottom. And so that kind of helps you remember that the y is the rise, the x is the run, you know. So this equation, let's go back to the first one. We're going to write these equations now, and I'll use red for this. This equation should be y equals m, and my m is 1 times x plus the b. Well, this equation can be simplified to just y equals 1x. And remember, we don't have to write the 1 in front of the x. If the x is by itself, we know that there's one of them, right? So it's just 1x. And then we don't have to write the 0 because we know that if there's not a plus b out here or a minus b out here, then our b is 0. So this is the better way to write that equation, since it's mostly simplified as far as we can get it. Now, this is the equation for the horizontal lines. They're always y equals something, and that y is the y value of every point on that horizontal line. And then for the Vux equations, you have x equals something, and that something is where it crosses the x-axis, and all of the points on that line have an x value of -2. And then this one, we have an equation of y equals, my slope was 2, so it'd be 2 times the x, and then my b was -3, so I'm going to write -3. You can write a plus -3, but it's best to write minus instead of plus negatives. They mean the same thing. So if it's negative, just write -3. If it's positive, just write +3. When you're identifying your B. Okay, so that takes care of how to recognize a lot of these graphs. And be careful when you're doing the graphs. For instance, it will not tell you whether or not your slope is negative when you're using this triangle method. This is a positive slope, so I kept it positive. But if this had been a negative slope pointing from this direction down, this one would be like a negative slope. You have to actually look at that line and say, oh, from left to right, it's going down, so it must be negative, and add that negative if that's the case. That wasn't the case this time, but if you have that pop up, you need to be aware of that. Okay, so that's graphs. Now, this is just another reminder of how to do horizontal and vertical lines. If it's horizontal, the slope is 0, and the equation is y equals whatever y value you have in all those points, and it's usually your y-intercept point, the 2 in that example there. And then this one, again, the Vux lines start with x. There is no y. So this is how you can kind of quickly tell if somebody gives you some equations and it's missing either the x or y. You know it's either a Hoy or a Vux. And the y is what's in the Hoy, and the x is what's in the Vux. So that's kind of how you can tell which one's vertical, which one's horizontal. And all of the x values are the same in every point on this line. And in this case, it's -5. Okay, so how do we do the same thing with tables? So again, we need to find the m and the x when we're trying to write that linear equation from a table. So find the slope of the line by counting the change in y and placing it over the change in x, reading the table from left to right or from top to bottom. Sometimes the tables are listed like this one on the left, where you're reading the points from top to bottom. And remember, these tables are just a list of points. Like 0, 3, that's the points, right? And that 0, 3 is actually your y-intercept point, because anytime the x value is 0, the corresponding y that goes with it on that point is your y-intercept point, or your B. On this second table, you're reading it from left to right. So sometimes they, present the tables from top to bottom, and sometimes from left to right, depending on where the x and y are located in the table. And this little delta symbol here that's triangle there, it just means change in y over the change in x. So that's what they're doing here. They're finding the change in the y, which was +2. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So that's my change in y. My change in x, 0 plus 1 plus 1 plus 1. So it's changing by 1 each time. So you just place that 2 over that 1. Let me get it. There we go. You place that 2 over that 1 and then simplify it. That's your slope. And then my b was this number here, because I know when the x value is 0, the other number in that coordinate point, and I always like to draw these so y'all can see these are just ordered pairs. That's all they are on that line. These are all some ordered pairs that were on that line. Same with these. You've got a 2, 0, 4, 3. This one didn't give you the b per se, but it does give you the slope, because the change in y was going up by 3 each time. The change in x is going up by 2, so 3 over 2. That's your slope on that one. And then you just fill it in the equation. Now, this is a situation where you don't have a b given to you. So if there's no, like this one, I said whenever the x value is 0, that the other y value that goes with it is your b. Well, there is no x value of 0 here. So there is a way you can find the b, and that is to plug it into this slope-intercept equation. So if I have this equation, y equals mx plus b, and I know my slope is 3/2, that's my m, right? My slope is m, but my x is 2. I'm just going to pick a point. You can do this with any of these points, and I'm just going to pick the first point, 2, 0. Okay, so my x is 2, my y is 0. So I'm going to plug a y 0 there. My m is 3/2. And m next to x there means that it's being multiplied. So I'm going to put it in a parentheses since I'm multiplying it. And my x was 2 plus b. Okay. So if I multiply these two, I'm just going to start it up here again. Okay. If I multiply these two, I'm going to get 6 over 2, because this is 2 over 1, right? So 6 over 2, 3 times 2 is 6. 2 times 1 is, so I'm going to end up with this. 6 over 2 plus b. And 6 over 2 is just a 3, right? 6 divided by 2 is a 3. So I have 3 plus b. And then to finish solving that equation, you would have to cancel out your 3 to isolate your b. And that means I've got to subtract 3 to zero that out using this inverse operations here. And 0 minus 3 on this side is just -3. So my b ended up being -3. So there is a way to find the b if they don't give it to you by giving you the point 0, b. Okay. Here's some tables. Let's practice this. Okay. First of all, let's identify our b. Well, here's our b. Whenever the x is 0, the other y that's with it is the b. So I know my b is -4. Okay. If I go through this one, there is no b listed. So I'm going to have to find that a different way. And then this one here does not have a b, but this one has a b, as you can see. There's my 0 in the x position. So that one would be my b. So I found a couple of b's so far. And I am going to come back to this one to see if I can find the b the same way I talked about that earlier. But in order to find the b, whenever it's not given to you, you need to find the slope first. So let's find the slopes next. I'm going to change to blue. And the change in y, looks like it's going down by 3 each time. 5 minus 3 is 2. 2 minus 3 is -1, and so forth. So if this one's going down by 3, I'm going to place that on top. And then the change in x goes on the bottom. And this time it looks like it's going up by 1 each time. And so that would be -3 over 1. And if I simplify that, it's just -3. So my slope is -3. My b is -4. And I can put it in the equation. -3 is my m times the x. And my b is -4. That's my equation of this line here. This one, the slope, the change in y is plus 4 each time. Looks like I'm adding 4 every time to get to the next number. And then on the other side, the change in x is plus 1 each time. So that being said, my slope is 4, change in y, over change in x. That's going to give me a 4 for the slope. Now that I have the slope, I can use a point. I'm just going to use this point here. You can pick any of them, any ordered pair, and I'm going to plug it into the y equals mx plus b equation. Remember, I don't have my b yet, and I need the b in order to write my equation. I do have an m. That m is 4, and I have a point, which is an xy. So I'm just going to plug those numbers in, substitute the y with the negative 17. That's my y in this point. And then I'm going to substitute the m with the 4. That's being multiplied times the x, which is a 1, plus b. 4 times 1 is 4. And then to isolate the b and to find out what the b is, I need to get rid of that 4. And to do that, I would subtract 4 on both sides. That's going to zero it out on this side. On this side, it's going to give me a negative 21. So my b is a negative 21. Now, I had to do a lot of work to make that happen, but now that I have it, I can write my equation. Y equals 4 times x minus 21. That's the equation of this line. One of the things that's interesting about this is when you go to find your slope, as you can see, it's counting up by 2 each time. So that would be a change in y of 2. And then on the x, it's not changing at all. We're adding nothing. It's all 5s all the way down, right? So if that's the case, that means we have something that we call undefined. You're not able to divide any numbers by 0. You can divide into 0, but you can't divide by 0. If you put this in your Desmos, which I'm going to demonstrate for you right now, if you put 2 divided by 0 in your calculator, see how it says undefined? Well, that's because it's undefined. You're not allowed to divide by 0 in mathematics. So because it's an undefined slope, we know that it's a vux. It's a vertical line. And didn't I say that vertical lines always have the same x in every point? And that's why the equation of vertical lines starts with an x. So it's x equals 5 because all of these x's are the same. So we know that's a vertical line. That's the equation of it. This one here, we have a change of 0 on the y value this time. And then a change of plus 2 on the x. So that's 0 divided by 2. And 0 divided by 2 is a slope of 0. And that should remind you that this is a HOI, which is a horizontal line. And with horizontal lines, my equation starts with y. There is no x in the equation. And it's y equals 6. It's the same y all the way down in every point on that line. How do we write linear equations in slope-intercept form from ordered pairs? The slope-intercept form of a linear equation is y equals mx plus b. First, find the slope of the line m by using the slope formula. So when you have ordered pairs, you do need to use the slope formula in order to find the slope. Next, locate the y-intercept point or the point 0b. Then write the equation in slope-intercept form, y equals mx plus b, by replacing the m with the slope ratio and replacing the b with the y-intercept number. Remember, if the y's are the same in the ordered pairs, the line is horizontal. If the x values are the same, the line is vertical. We kind of talked about that before, but it's just reminding you. So our first one is this one. And as you can see, I've got 2 points. This is my first xy. This is my second xy. So I'm going to label this one my 1s. This one, my 2's. And so that means I'm going to subtract y2 minus y1. I'm following the formula over there on the right. So that would be 3 minus 7. On the bottom, I'm subtracting the second x minus the first x. So that would be 0 minus negative 5. Now, 3 minus 7 is negative 4. And then 0 minus negative 5 is actually a positive 5. So there's my slope. And my b is actually located right here. Remember, when the x value is 0, the other number in that point is your b. So now that I have my m and my b, I can write my equation. Y equals the m, which is negative 4/5. I cannot simplify that anymore, and it will give me a decimal if I try to divide it, so I'm not going to. Okay, negative 4/5 times x, and then the b was positive 3, so I'm going to write a plus 3 out here, and that's my equation of that line from those points. All right, the next one, I've got the same thing going on, so let me change colors. Let's go to orange this time. All right, so we have an xy, we have an xy here and here. Every point is x then y, just alphabetical order. And then these are my 2's. And again, I'm labeling the 1's on the left and the 2's on the right because we read these from left to right. And so if I use my formula, I'm going to take the second y and subtract the first y from it. So that would be 9 minus negative 2 on the top. On the bottom, I've got 1 minus 0. And that would give me an 11 over 1. And 11 over 1 is just 11. So my slope is 11. My b is negative 2. Remember, when the point starts with 0, the other number is your b. So my b is negative 2. And now that I have both the m and the b, I can put it in my equation. Y equals 11 times x minus 2. As you can see, I'm just replacing the m and the b with those numbers. All right, the next one is the same kind of problem. Let's change it to, here we'll do purple this time. All right, so again, I've got xy. I've got xy. These are my 1's. These are my 2's. So second y minus the first y, that would be 0 minus 8 on the top. And then second x minus the first x, that would be 0 minus 2 on the bottom. And this time we end up with a negative 8 over a negative 2. And I can simplify that. Negative 8 divided by negative 2 is positive 4. One of the things that you might get stumbled on is when you have a negative in the numerator and the denominator, that will make a positive number. So just know that if you get one negative, the whole fraction is considered negative. But if they're both negative, the whole fraction is considered positive. Our b is 0 this time, because as you can see, when the x is 0, the y is also 0. So the equation would just be y equals 4x. We do not have to write the plus 0 out there. If you write plus 0, it's not necessarily wrong. It's just you don't have to write it, and you will never see it written that way. So it's best not to get into the habit of writing that plus 0, because we know if we add a 0 to a 4x, it's just going to be the same thing, right? So try to remember to leave that off if you can. This plus 0 here. Okay, next one. All right, so I've noticed something about this already. We'll use green. Okay, so again, we got xy, x1, y1's on this one, and then we got x2, y2 on this one. Okay, so second y minus the first y, that would be 3 minus 3 on the top. That's a 3 there. On the bottom, we have 20 minus 19. So what we essentially have is 0 over 1. And 0 divided by 1 in my calculator gives me a slope of 0. This is a HOI. When you have slope of 0, that's a horizontal line. And as you can see, my 3's are the same. Every time you have a horizontal line, your y values will be the same. And that is your b. And that is also your equation, y equals 3, because every point on that line has 3 in the y position. The last one, what color have I not used yet? Let's use red. Okay, x1, y1, x2, y2, and so if I plug it in the formula, it's going to be my 8 minus negative 13 on the top. And then on the bottom is 17 minus 17. So what I have on the top is 21. What I have on the bottom is 0. And when I put that in my calculator, I'm going to get a slope of undefined. You cannot divide by 0. And if I look at those points, I can also tell that it is a Vux line because this is a Vux. I forgot to write HOI over here, but this one was a HOI line. Because it's the x's are the same. Remember, the x's are always the same in vertical lines. So since those x's are both 17s, my equation is x equals 17. There is no y in a vertical line equation, just as there is no x in a horizontal line equation. All right, so great job, y'all. Remember to find the slope of the graph by counting the rise over the run between 2 points. Be sure to look to see if the line is positive, moving up from left to right, or negative, moving down from left to right. Remember to find the slope of a table ratio of the vertical change rise over the horizontal change run, rise over run. Remember that you visually see where a line crosses the y-axis on a graph to find the y-intercept at point 0b. Finding the y-intercept of a table is to locate the point where the x is 0. Remember to check for where the horizontal line graph crosses the y-axis to write the equation in the form of y equals b. Remember to check for where the vertical line graph crosses the y-axis to write the equation. Oh, that's not right. Hang on, let me fix that. That should be x equals a number. We don't know what that number is. Remember to check for where the vertical line graph crosses the x-axis. I didn't change this. It should be x-axis. That should be x. And it's not b. It's x equals whatever number the x is on all the points in that vertical line. And remember to use the slope formula to find the slope of a line using ordered pairs and identify the y-intercept by locating the point 0b. And at any time, if you have the m and you have one of the points, x and y, you can always insert or substitute that y, x, and m in the slope-intercept form equation, y equals mx plus b, and solve to get that b if necessary. And I believe that's everything. So hopefully this was helpful. And now it's time for me to say, it was lovely teaching you math today. Bye-bye.